When you look at this collision in front of you, it probably won't be obvious that in this collision, the total momentum before equals the total momentum after. Looks like the total momentum after is 26, and the total momentum before is 22.5. And that's something you may conclude if you forget that you don't add up vectors at an angle like that, 13 plus 13. You add them up vectorially. Let me see if I cannot do this. Yeah, so these two vectors, 13 plus 13, must be equal to 22.5 if this collision is represented correctly. Um, the vector addition of 13 and 13 at these angles does equal 22.5. That's what we're going to talk about today. What happens when you have a collision where the objects have two directions? In the beginning, there's only the yellow sphere only has one direction, um, and it has no y momentum. It only has x momentum. When we look at the two spheres afterwards, the top sphere has x and y momentum, and the bottom sphere has x and y momentum. And what we'll learn a little bit later is that the x momentum before equals the x momentum after. The y momentum before equals the y momentum after, and that's what we're going to get into today. So this is collision in two dimensions. This is a worksheet that says the momentum is conserved in the y. Let me get that. In the y and the x directions, in the vertical direction and the horizontal direction. So the total momentum in the x direction before equals the total momentum in the x direction after, and the total momentum in the y direction before equals the total momentum in the y direction after. And so we have a conservation of momentum in two different directions. So if the angle between the two vectors that you're adding is 90 degrees, I hope you remember that. How would you add those momentum vectors? You'd use the Pythagorean theorem because momentum's a vector, and we'll follow the rules of addition for 90 degrees. We use the Pythagorean theorem. So let's look at first problem. You've got an eagle with this mass moving with the speed, and it collides with a second eagle with a different mass, a little smaller, 5.6, with a different speed. It's moving perpendicular to the first, and here's the picture of this the momentum before. You're told they're perpendicular, so this means this is 90 degrees. They collide, and they hold on to one another. So they become one object. We'd call this an inelastic collision. What is the speed of these two um, eagles after the collision? The eagles hold on to one another, and this is what this problem gives us. The mass of eagle A, velocity of eagle A, mass of eagle B before, velocity of eagle B before. This is all the before. So what's the speed and direction they are moving after the collision? So once again, total momentum before, still true, it'll always be true, equals the total momentum after. And so let me just show what we talked about before. This has only x momentum. So, and this says only y momentum, but together, if you look at the resultant of the two, the x momentum before equals the px after. The x momentum, this only has y momentum, so these two momentums add vectorially to create this momentum. This is the total momentum of the eagle, two eagles connected with a single velocity. So again, total x momentum before this equals total x momentum after. Total y momentum before equals the total y momentum after. They join together to become one mass and one velocity. So let's find the total momentum before. We've got 90 degrees, so it's we can use the Pythagorean theorem. So the p total before is going to be equal to, using the Pythagorean theorem, 4.3 kilograms times 7.8 meters per second. All of that squared, a squared plus b squared equals c squared. The momentum of the other b was 5.6 kilograms times 10.2. And all of that, whoops, let's get rid of that. All of that squared, and that, oh, let me just put the squared over here, right there. So there's the total momentum before. What does that equal? The total momentum after. P total after. What does that equal? Well, that equals the combined mass 4.3, 5.6, 9.9 kilograms. The two eagles connected times the velocity that we don't know, the velocity of the joined eagles after. So now it becomes a math problem. Whatever the P total before this equals that. The P total before equals the P total after. Let's see what we got over here. So it looks like this. So the total momentum before is here, which equals the total momentum after, the combined mass times the velocity we don't know, and we get a solution of 6.7, rounding it to two significant digits. And here's the solution in another way. So that's the speed after the combined speed, and then they ask you to find the what's the direction. So let's look at our picture up here. You have the two components. You have how do you find that angle? Well, you use tangent because it's opposite. Tangent theta. What is the angle? Equals the y momentum, which is, let me see, the y momentum would be the total y before equals the total y after, right? The py over the px. And all I have to actually use, how do I get px and py? Well, I know the py before, and I know the px before, so why not use those? Because the py before equals the py after, and the px before equals px after. So tangent theta, what's the py before? Let's take a look. I can use, let's see, that's the b is the py before. So let me look at b. So it's 5.6. Let's see, b is what I'm calling my y in my picture. 5.6 times 10.2. 5.6 kilograms times 10.2 meters per second. Once again, I know this is odd. That's the total y momentum before, which also equals the total y momentum after this. So what's the total, the x momentum before? Let's take a look. That would be a 4.3 times 4.3 kilograms multiplied by 7.8. And that's how I can find the angle, so I get the direction. So the tangent theta equals 1.703. Then you do the inverse tangent, a shift tangent, and it rounds up to 60 degrees. So what's the direction? It's 60 degrees. 60 degrees relative to eagle A. 60 degrees relative to eagle A. What does that mean? Take a look at the picture. Let's go up to the picture. Here's eagle A. Eagle A's initial path, and it's 60 degrees from his or her path. So there you go. So the answer is 60 degrees is the direction relative to eagle A, and the velocity was 6.7. That's probably a lot to digest. So let's summarize. When you have two uh, objects going 90 degrees, the total momentum before is found with the Pythagorean theorem: a squared plus b squared equals c squared. That's straightforward. The eagles combine; they have a single mass and a single velocity, and then it becomes a math problem. How do you find the angle that in this picture, the angle that the two eagles make? Um, it's the y momentum divided by the x momentum. You can see in the picture, tangent is opposite over adjacent. Uh, how do you find the y momentum after? This is how they designate after. Well, the y momentum after equals the y momentum before, because the law of conservation momentum says the y momentum before equals the y momentum after. So If I want to find the y momentum after, I can simply use the y momentum before. If I want to find the x momentum after, I could use the x momentum before. So that is quite a problem. And I think might be a good place to stop.